The universe has a real edge, not a wall, but a horizon defined by light speed and time. And what physics says lies beyond it is either infinite, looping, parallel, or collapsing. And right now, we can't rule out any of them. That sentence is not poetry. It is the most honest summary of where cosmology stands today. For 13.8 billion years, light has been racing toward you from every direction simultaneously. Everything that light has managed to reach you from sits inside a sphere roughly 93 billion light years wide. That's wider than you'd expect, because space itself stretched like taffy during the early universe, carrying distant objects far beyond where they started. Everything within that sphere is your observable universe. Everything beyond it is cut off, not because it doesn't exist, because its light hasn't arrived yet, or never will. Look at the night sky long enough with a powerful enough telescope, and you'll eventually hit a wall. Not metal, not stone, a glow. A faint, uniform shimmer coming from every direction at once, the same in every patch of sky, warm and ancient and absolutely everywhere. That glow is the oldest light in the universe. It's radiation left over from 380,000 years after the Big Bang, from the moment the universe finally cooled enough for atoms to form and photons to move freely for the first time. Before that moment, the universe was so hot and so dense that light couldn't travel at all. It was like trying to see through a wall of fire. That wall of fire is the edge of what we can ever observe. Everything we know about stars, galaxies, black holes, and cosmic history fits inside it. And beyond it, physics gives 4 completely different answers about what's there. Before we get to those 4 answers, let's destroy the assumption most people carry into this conversation. When you hear edge of the universe, your brain pictures a boundary, a wall you could fly a spaceship toward, reach, and then peer beyond, the way you'd peer off the edge of a cliff. Space doesn't work like that. There is no outside. Asking what's outside the universe is like asking what's north of the North Pole. The question sounds sensible. It isn't. The universe isn't a bubble sitting inside some larger space. It's not expanding into anything. Space itself is stretching. Every point in the universe is moving away from every other point, not because objects are flying through space, but because the space between them is growing. Picture a balloon being inflated. Every dot on the surface gets farther from every other dot, but the surface doesn't expand into anything, it just stretches. And crucially, there is no center, and there is no edge on the surface itself. Our universe works the same way, just in 3 dimensions instead of 2. So the cosmic horizon isn't a physical place, it's a boundary in time, not space. It marks how far light has had time to travel since the universe began. Objects beyond that horizon aren't somewhere else. They're in the same universe, obeying the same physics, made of the same particles. They're just causally disconnected from us right now. No information from them has reached us yet. This matters enormously because it means we have to infer what lies beyond from what we can observe. And the most powerful tool we have for that inference is that ancient glow. Here's the first decision point, and this one requires actual thought before you continue. We've measured that ancient glow with extraordinary precision. What we found is that space is flat, not curved like the surface of a ball, not saddle-shaped like a horse's back, flat, accurate to within 1%, which in cosmological terms is essentially perfect. Now, before I tell you what that implies about the universe's size, think about it yourself. If space is geometrically flat, the way a sheet of paper is flat, what does that tell you about whether the universe is finite or infinite? Pause and work that out, because the answer is stranger than most people expect. Flat geometry, mathematically, is only fully consistent with space that is either infinite in extent or so unimaginably large that its curvature is completely undetectable. Think of standing on Earth's surface. The ground looks flat. It is, of course, curved, but the curve is so gentle at human scales that you can't feel it. Now imagine the universe's curvature is so gentle that even with our best telescopes covering 93 billion light years, we can't detect the bend at all. If the universe is curved and finite, physicists calculate it would have to be at least 300 billion light years across, more than 3 times the width of everything we can see, before we'd notice. The universe might be curved, but if so, it's so enormous that it may as well be infinite for any practical purpose. And that leads directly to the first answer physics offers for what lies beyond the horizon: more of the same. If space is infinite, truly infinite, then everything that can happen does happen somewhere. The number of ways matter can be arranged in any given region of space is gigantic, but not actually endless. There are only so many possible combinations of particles in a volume the size of our observable universe, the way there are only so many ways you can arrange a shuffled deck of cards. In an infinite universe, every possible arrangement eventually repeats, including stars just like the Sun, including planets just like Earth, including, according to the math, an exact copy of you, sitting somewhere impossibly far away, reading this exact sentence, having exactly this thought. Let that sit for a moment, because this is the second decision point. If the universe is infinite and every possible arrangement of matter repeats, then right now, somewhere out there, is a version of you that made different choices. A version that never clicked on this video. A version that's currently looking up at a night sky very much like yours. Does that make you feel connected to something vast and meaningful? Or does it make you feel like none of your choices matter? That every version of you already exists, every outcome already happened, and free will is just a local illusion? Both reactions are reasonable. Both are philosophically loaded. And both hinge entirely on whether that first answer, infinite space, repeating arrangements, is the correct one. The second candidate answer is that space is curved and finite, but has no edge, like the surface of that balloon, but in 3 dimensions. Travel far enough in one direction and you'd eventually return from the other. The universe would be a closed loop, like a 3-dimensional version of a video game where you walk off one edge and reappear on the other. Current measurements say that if this is true, the loop is at least 300 billion light years across, far too large for us to detect any sign of the looping pattern. We'd need to see the same cosmic structures repeated in opposite directions, like reflections in mirrors. And so far, we don't. The third answer comes from inflation, the leading model for how the universe began. The idea is that our universe started as an incredibly tiny region that expanded at a speed that makes fast sound like an insult, doubling in size faster than light can cross it, over and over in a tiny fraction of a second. The leading version of this model predicts something disturbing. Inflation never fully stops. It keeps churning, producing new bubble universes constantly, each one expanding from a different starting point, each one potentially with different physical constants. Beyond our horizon might be regions where atoms can't form because the forces holding them together are slightly different, regions where stars can't ignite, regions where the rules of chemistry don't apply. These wouldn't be different places in our universe, they'd be genuinely separate bubbles, each one causally disconnected from ours forever. We could never reach them, see them, or detect them directly. We can only infer they might exist from the same physics that explains why our universe inflated the way it did. The fourth answer arrived recently, and it's the most unsettling of all. In 2025, the DESI telescope, which mapped the positions of tens of millions of galaxies to trace how dark energy behaves over time, released data suggesting that dark energy, the force that drives the universe's expansion, may not be constant, it might be weakening. This is contested. Many cosmologists treat it as a measurement that needs confirmation. But if it's real, if dark energy really is losing strength over time, then the expansion of the universe could eventually slow, stop, and reverse. The universe would contract. Everything in it would fall back toward everything else, compressing until the entire cosmos collapsed into itself. Physicists estimate this could happen within 33 billion years, which is a very long time, but also genuinely finite. In that scenario, beyond the edge isn't a different region or a parallel bubble. It's the same universe heading toward its own end. Now, before the final answer, here is the third decision point. The DESI data is real. The signal is there. But data can be misleading. Instruments have systematic errors, models have hidden assumptions, and a single unexpected result often turns out to be noise. So right now, cosmologists face a genuine choice about how to weight this evidence. 3 options. It's a measurement error that better instruments will correct. It's a real signal that fundamentally changes our understanding of how the universe ends. Or it's evidence that our universe is just one of many that expand, age, and eventually collapse. A cycle of bubble universes being born and dying, with ours somewhere in the middle. Think about which of those 3 options you find most compelling. Notice what it is in you that makes you lean one way. Then remember that none of the 3 can currently be ruled out. Here is what should genuinely unsettle you. The more precisely we measure the universe, the less certain we become about its fundamental nature. 100 years of increasingly accurate astronomy have told us the universe started from a single point, is expanding, and is 13.8 billion years old. That's extraordinary knowledge. But those same measurements leave completely open whether the universe is infinite or merely enormous, whether it's the only universe or one of trillions, and whether expansion is permanent or temporary. Better data hasn't resolved the question of the edge. It's made the uncertainty more precisely defined. We now know exactly how much we don't know. And here is the last thing to hold on to. Our cosmic horizon is moving. As the universe ages, light from farther and farther away finally reaches us. New regions come into view. But dark energy is also accelerating the expansion, pushing distant galaxies away faster than new light arrives. We are, slowly and irreversibly, losing access to the universe. About 45 billion galaxies sit within our current horizon. Eventually, even the nearest galaxy clusters outside our local neighborhood will redshift beyond detection. Their light stretched so thin it becomes invisible, like friends walking away into a fog that deepens as they go, until no signal from them reaches you anymore. They won't have disappeared. They'll still exist. You'll just no longer share a universe with them, not in any practical sense. The observable universe is shrinking. Our window is closing. And the 4 answers physics gives for what lies beyond the edge, infinite, looping, parallel, collapsing, all agree on one thing. There is far more out there than we will ever see. The edge isn't where the universe ends. It's where our knowledge ends. And those 2 things may never be the same.